our first topic is to talk about what are electromagnetic waves. So electromagnetic waves come in a spectrum. So let's write down the different parts of the electromagnetic spectrum. So we're going to start off on this side over here with radio waves, which I'm going to abbreviate with the letter R. And then next to that is going to be the infrared, and another name for infrared light is going to be heat. So if something is hot, like a stove, it's giving off infrared light. So infrared is part of the electromagnetic spectrum. Okay, then next to it is going to be the visible part of the spectrum. And then next to that is going to be the ultraviolet part. So ultraviolet is the stuff that you get from the sun. It could give you a sunburn. It could also give you skin cancer. It could also give you cataracts. Then next to the ultraviolet is going to be X-rays. And then finally, next to that is going to be the gamma rays. And so this is the Greek letter G called gamma. So this is the electromagnetic spectrum. Now, I would also like you to know Roy G. Biv. So the different parts of the visible part of the electromagnetic spectrum. And so we can remember this by remembering Roy G. Biv. But we need to reverse the letters on it because of the way that I've got my spectrum written here. So I'm going to put R over here. And so I'm going to say it's Roy, and then G, and then Biv. And so if you want to, you can put an I in there in between the V and the B for the indigo, but it's going to be red, orange, yellow, green, blue, and violet. So those are the colors of the rainbow. Notice that red is next to infrared, and then violet is next to ultraviolet. So hopefully that will keep it straight in your head, the order in which to put the visible light. So if you look at this chart here, it's organized the same way. So the very top part is showing you the wavelength. So in previous episode, we talked about the wavelength as being the distance that a wave travels before it repeats itself. So that was called the wavelength. So notice that radio waves have the largest wavelength, and then as you go this way, the wavelength gets smaller. So let me represent that by putting a gigantic lambda over here, and then let's put a little lambda over here. So that large wavelengths, and then as you go across the spectrum, the wavelength gets smaller and smaller. If you got really good eyesight, you'll be able to see the wavelength written in terms of meters, and how it starts out being, could be as large as a kilometer over here. But by the time that you get down to here, we're talking about the size of the nucleus of an atom. When we're talking about visible light, the size of visible light is roughly the size of the atom itself. Okay, another piece of information that you should know is the frequency. So how does the frequency of light vary as you go across the spectrum? It's the exact opposite. So that the frequency is going to be very small over here, and it's going to be very large over here. So it's the exact opposite of what the wavelength is going to do. So on the exam, if you were one of my students, I could say, which has a larger frequency, an X-ray or green light? Okay, X-ray, green light. So the X-ray is going to have the larger frequency as compared to the green light. Or I could say something about the wavelength. How does the wavelength of violet compare to the wavelength of red? And so red is going to have a larger wavelength than what violet is going to have. But it is going to be smaller than a radio wave. Another thing I want you to see is energy. So what is the energy of a single particle of light, which we're going to call a photon? We'll talk more about that next. But I'm going to put down a very small e over here, and then put down a very large E on this side over here. So as you go across the spectrum, the energy of the light is getting larger and larger. So to keep this in your head, just think of the Incredible Hulk. So the Incredible Hulk gets his energy from gamma rays. So gamma rays have the most amount of energy. All right, at the bottom, it shows what's the frequencies and the wavelengths of visible light. So if you're interested in that, go ahead and take a look at it. But I would give you a chart like that on the exam if I was going to ask you what's the wavelength of the color red. Another thing before I go is you might be saying, well, what about microwaves? Where do microwaves go? Well, microwaves are a type of radio wave. So when you talk about AM radio, FM radio, CB radio, telephone communications, so all of this are various types of radio waves. All right, let's take a break, and when we come back, we are going to continue to talk about what are electromagnetic waves.